Now let's consider this example. You can pause the video and try the question on your own. Don't forget that no pain, no gain. Mathematics is not a spectator of sport. Pause the video and try the question on your own. This video together with other videos are available on a pen drive for sale. Very, very affordable. Call the numbers for a copy for yourself. Now the question says that the figure below, that's this figure, shows two circles intersecting at B and D. So it is intersecting at B, and then now the radii OB and DP, that is OB and D, OB and DP are 4 centimeters and 4 root 3. So OB, that is 4 centimeters, and then DP, that's 4 DP 4 root 3 centimeters. Now, if triangle ABD, triangle ABD is equilateral, triangle, very important, equilateral, all the sides are equal, and since all the sides are equal, each angle in such a triangle is 60 degrees. Now, calculate the area of sector OB, that's OBXD. Okay, so the first one, let's consider, that's the circle. So we have the circle, and then let's consider a sector, a segment, center. So the radius is what? That's 4 centimeters. This is also 4 centimeters. We don't know the angle, and the same chord subtending an angle over here. Now this is A, this is B, and then this is D. There's D. Now we are being told that ABD is isosceles triangle. Hence the angle here is 60. This 60. The angle here is also 60 degrees. The angle here is also 60 degrees. Equilateral triangle. All the sides are equal. All the angles too are equal. Now, we know this is O. This is O. Now, BD or DB is a chord. The angle a chord subtends at the center is twice the angle that it subtends at the circumference. So all that we are saying is that BOD, angle BOD is equal to 2 times, that is BAD. BOD is equal to 2 times BAD. The angle a chord subtends at the center is twice the angle that subtends at the circumference. So we know BAD, that's 60. So 2 times 60, and this is giving us 120 degrees. So the angle here is 120 degrees. First on sector OBXD. Sector, we know there's X here. OBXD. How do you find area of a sector? Now we know that area, so still on the first one, area of a sector is giving us theta over 360 times pi r square, area of a sector, theta over 360 times pi r square. What's the theta? That's 120 over 360. What is the pi? That's 22 out of 7. Pi, 22 out of 7. What is the radius? The radius is 4, so we have 4 square. Okay, when we punch this on a calculator, we are getting that 16.76190. Now, the question says, are we giving the approximation? No, we're not giving approximation. Now, let's leave it to 3 significant figures. First, second, third. So that is 16.8 centimeters squared, because this 6 can change the 70 because it's 5 and above. Okay, now I says we find segment BXD. So segment BXD, and that is the segment over here, segment BXD. So the second one, area of segment BXD. Now area of a segment is equal to what? That's area of a sector minus area of the triangle. Area of segment is equal to area of sector minus area of triangle. Now area of sector, that's theta over 360 times pi r squared. Area of sector. Now area of triangle, that's half r squared sine theta. That's area of segment BXD. Okay, what do we need from here? Theta, do we know theta? Theta is 120, pi 20 out of 7. We know our radius to be 4. So we know everything here. So from here, what's our theta? We have 120 out of 360. We are just substitute pi plus 22 out of 7. What is the radius? Our radius is 4. So you have 4 squared minus half r, that's 4 squared sine 120, sine 120. And when you punch this on the calculator, what do you have when you punch this on the calculator? When you punch this on the calculator, we are getting that's 9.8337. That is when you punch this on the calculator. Let's leave it to 3 significant figures. That's first, second, third. 9.83 centimeters square. Now let's consider the second part. The second part says that we should find that area of the shaded portion. So this shaded portion, you see, we can consider the chord here. So we have two segments. So we can say A1 and then A2. Now here we can name this one, that's A1. Then let's consider the second circle. We have the segment center. Now in this case we don't know the angle here. There's no reference, we don't know the angle here, but this is 4√3, this is also 4√3. So how would we be able to find the segment over there? Do you know the angle? We don't know the angle. We don't know the angle. Now let's, okay, so this is our B and then this is our D. Now can we find the length BD? Can you find the length BD? Yes. You see, using this, the first diagram, we can find the length BD. This 120 degrees. So you see, we have this triangle. We know this is 4 centimeters. This is also 4 centimeters. BD, we don't know the BD, but then the angle here is 120 degrees. And from this, we can use two things, either the cosine rule or the trig ratios. Now using the cosine rule, where the angle is facing, so you have our BD squared. That is where the angle is facing. And this equals, that's 4 squared plus 4 squared minus 2 times 4 times 4 cos the angle. What's the angle? The angle is 120 degrees. So 4 squared, we have 16. 4 squared, we have 16. 2 times 4, 8. 8 times 4, we have 32 cos 120 degrees. Now 16 plus 16, This is 32 minus 32 cos 120 degree. Now 32 minus 32 cos 120, and this is equal to 48. So that is our B D square. That's 48. Won't find the BD. The square will become square root. So our BD is equal to square root of 48. BD. So square becoming the square root. And using the calculator, this is giving us 4 root 3. So either we use the cosine rule like this or. So 4 root 3, you can see that it is having a relationship here, and 4 root 3 also over here. Or we use the trig ratios. We have this triangle, the angle that is, this is OBD. We have OBD, bringing the perpendicular distance from O. Now, this bisect the angle. So we know 120, so this is 60 degrees. This is also 60 degrees, because 120, and the line from the center to the chord bisect into 2 equal parts. This is 4 centimeters. This is also 4 centimeters. Now, sine 60 degrees, sine 60 degrees, sine 60 degrees. That's opposite. That's our BM, where the angle is facing BM over 4. We are using SOHCAHTOA. SOHCAHTOA. That's what we are using. So opposite over hypotenuse. So sine 60 opposite is BM. SOHCAHTOA. So that's opposite over hypotenuse, opposite over the hypotenuse. So clearly from here, our BM is equal to 4 sine 60 degrees. This multiplying that, and 4 sine 60 degrees is giving us that's 2 root 3, 2 root 3, 2 root 3. But then BM is the same as MB. Therefore, we know our BD is equal to BM plus MD. BM plus MD. Now, what is BM? That's 2 root 3, 2 root 3. And this is for 2 plus 2, 4. And then we bring in our root 3. Wow, that's nice. That's very, very nice. So clearly, let's see. You see, this is 4 root 3, this is 4 root 3, and this one is 4 root 3. Yeah, that is the BD. This is 4 root 3. So we know our A1. Have we worked for the A1 already? Yes, we worked for the A1 already. So we need to know our A2, because the total area of the segment will be A1 plus A2. Now, how do you find the A2? How do you find the A2 over here? Do you know the angle? Yes, the angle here is 60 degrees. Why the angle there is 60 degrees? Because we have 4 root 3, 4 root 3, 4 root 3. It is an equilateral triangle. All the angles are equal to 60. Yes. So our A2 will be area of the sector, which is theta over 360. That's A2 area of the sector. Area of the sector minus area of the triangle. That's area of the segment. Area of the minor segment. That's area of the sector minus area of the triangle. Now, how do you find area of the sector? That's theta over 360 times pi r squared. Area of the triangle, that's half times r squared sine theta. What is our angle theta? We have our angle to be 60 degrees, so 60 out of 360 pi, 22 out of 7 r, that's 4 root 3, 4 root 3 square minus half r, 4 root 3 square sine theta, and then the angle is 60 degrees. Now when you punch this on the calculator, this is giving us, when you punch this on the calculator, we have this to be 4.3582. That's what we have. So our total area, that's A1 plus A2. But the total area, that's A1 plus A2. What is A1? What did we get first? What was the first area that we had? The first area that we had was 9.83337, and then the second area, that is 4.3582. So our A1 plus A2, our A1, that's 9.8337, our A2 is 4.3582. That is our area. And clearly, this plus, what is this plus this? When you add the two, we are getting, that is 14.1919 centimeters square. We're not giving any approximation. Were we giving approximation? No, we're not giving any approximation. Either we leave it this way or to three significant figures. That is 14 point, the now changes, that's 2 centimeters square. That's it, very, very easy. We've solved a lot of questions. Please play back the videos for better understanding. We've done a lot of things on mensuration 1. We've done a lot of things, even including this very subtopic area of a minor segment. We've been able to solve a lot of questions. Please make sure you get the video and then you'd enjoy them. Please solve questions on your own. Call the numbers you are seeing on the screen right now for a copy of the pen drive. It is very, very affordable, and it will be of immense help to you. You'd easily get A1 in your forthcoming exam. Is it NOVDEC? Is it WASI? Get my videos. It will be very, very easy for you to pass your exams.